Yes, hi, welcome to this fifth unit of MFP here available. So this is the last unit I am going to discuss here. So you can see my here, you can see what is happening is this is a totally it is dependent on the 3D printing. So what is a 3D printing is another name of 3D printing is additive manufacturing. So here let me take a first question, ma. So the first question is stating that explain in detail the steps involved in additive manufacturing with a neat diagram. So you have to tell what are the steps involved in this manufacturing process. Here you can see this is a CAD model. First you have to design it. Then there is a second step here, conversion of STL file. So first you have to design any model in the CAD software in mechanical engineering, and then you have to convert into STL file. Here it is STL full form is stereolithography file, which will be divided into slices, and it is sent to it is sent into this manufacturing machine where that printing is done here. So you can see here backside input is given. One is dissolvable material. Dissolvable material is coming from one side, entering into this machine, and the photopolymer materials both are coming here, and they are some nozzles are arranged here. Okay, some UV light is coming here. So UV light is what it is doing, it is printing this onto this object. So this object can be moved in this direction, x-axis, and this is a build platform. This build platform is having support. This support is can be into y, sorry, z direction. This is a z direction. This is a x direction. So it can be moved from this last to this last, and from up to down, down to up, two directions you can see in this 3D printing or additive manufacturing. So here, this is the whole setup. You have to draw this one, and this is object support. So object is created by using these nozzles, and this UV light is also helping us in order to inject this jet into this object. Here, CAD model, the process designs by creating a 3D model of the desired object. So whatever the desired object shape you want, here it is a some object is kept here, okay, it is printing using computer aided software or by 3D scanning to an existing object to generate a digital file. You have to create a digital file. CAD model is prepared, it is converted into digital file which is called as STL. So the CAD model is converted into standard file format, typically STL, stereolithography, which will be divided into describe the external closed surfaces of the model, enabling it to be read by the 3D printing software. So this is a 3D printing software diagram where it will be having a platform, object, nozzles, UV light is used for photopolymer material, dissolvable material, both are coming and meeting into this. And this can be moved into two directions. This is like crane type here. So this is the machine which is, I think, a half a room size, which will be printing your objects, whatever you want. Now, coming to this second question, describe the classification of classifications. What are the classifications? Simple, with suitable diagram. So here you can see this classification. It is a additive manufacturing. So means additive means 3D printing, which is divided into additive layer manufacturing, non-layer manufacturing. So without layers also you can do. With layers you can do. So this is where material bed is used, because you have to build layer by layer, then you need a bed here, and also material decomposition. Material will be melted and it will be printed layer by layer. This is coming into additive layer manufacturing. In non-layer manufacturing, material deposition process which is directly done, and also motionless materials process can be done here. So if you are coming to this explanation, additive manufacturing process are classified by the this ASTM committee. This is a American standard tool machines. Some standard committee is there into 7 categories. We can see based on the how materials are deposited. So what kind of materials, how materials are deposited and they are joined, includes that one classification. So it is some types you can take, VAT photopolymerization. Photopolymerism means the name itself says photo, so it is using some light in order to make this process. Material extrusion process, it is extrusion process, which is added by this 3D printing. and power bed fusion method. So fusion method means some melting process system. These methods build 3D parts layer by layer from 3D cap. So layer by layer you are going to mix. What are the materials used here is plastics, metals, ceramics, etc., etc. But the three main topics are plastics, metals, and ceramics. If I am not wrong, I am going to this third question, ma. In the third question, you can see this. Explain extrusion based additive manufacturing process, ma. Here we can see this is the extrusion based ma here. So what is happening is this bed is moving in the Z direction. This is a build platform. So deposited layer by layer ma here. So it is continuously these rollers are there ma. This filler material is coming. It is a heating material. In this heating material, it is this wire is coming and it is melting and depositing into liquid ma. Layer by layer, you can see this how the axis is shown nozzle movement in x and y z directions. So x direction and also we can move in y direction also we can move, x direction also move, z direction of the bedding ma, up and down we can move, which is a super automatic process. So extrusion is done. This heating nozzle is used. The nozzle, simple nozzle is heated nozzle here, and it is a filler metal coming continuously from the backside. So coming to the definition, extrusion-based additive manufacturing, commonly known as a fused bed deposition modeling. So it is a fused because the wire which is coming is fused into jelly material to deposit or material extrusion MEX builds 3D parts by heating thermoplastic filaments or paste-based materials, which extrudes it layer by layer through a nozzle on a blade platform hitch. This most effective process is widely used for prototyping and producing functional components using polymers, composites, and also sintering. So they are what they are composing now. What kind of output is coming means polymers, composites, sintering, metals, ceramic paste are coming. So what are this one here surface finish is there. In the surface finish you can see the layered stair steps effects results in a lower surface quality. Here some lower surface quality is finished because the surface you can see open is open to the environment, often requiring post processing. After that you have to do some machining process. Lower accuracy limited to material nozzle thickness leading to lower resolution compared to photopolymerization. Some materials are limited here. Some nozzle is there, thickness is there. So depend on that nozzle thickness only it is going to be done. So this is you can see here driver pulley. So driver pulley is sending the wire continuously. The material to be extruded coming to this heating nozzle. It is getting heated. It is deposited in the x direction, y direction. So there is a bed which can be moved like spring in the z direction also. So this is the explanation of extrusion So next we are coming to fourth question. The fourth question you can see explain power bed fusion power bed This is one of the type of this one as I said. So here you can see coming to the definition, power bed fusion is a high precision additive manufacturing process that uses a laser or a electron beam. So laser or electron beam. Some electrons are selected here which are used as a and they are used as like a beam. They are imposed. So you can see this is the metal is melted here. The uniform layers of powered material is in a powdered powder bed So this is the bed here. This is the bed which is we are giving powder, and after this powder delivery is done here. The rollers are there. The rollers are here. Okay. So here also you can see some beam is there. It is sending here to fabricate. Okay. This can be moved up. So it can be moved up and it can be moved down both x direction, z direction, and y direction is there. A roller bed spreads over a build platform. This roller is spread over this powder It is going to sintering it, and when descends after each fused layer, allowing complex dense parts to be built often without supported structures. So you can also build this one. Here you can see some energy system. We can arrange a electron beam or laser beam, which is going to after this powder is there, after rolling is done. After that, this is a fabricated object. You are sending this photon light inside this power bed, so which is doing this fabrication work, and then it is going down. This bed is going down in the Z direction. This is a powder bed fusion. This powder is first of all rolled, then it is making some arrangement of photons and electrons here in the second phase. So this is the explanation of that one. So fifth question you can take describe the future scope and challenges of additive manufacturing. So future scopes, what are there you here directly diagram is there, you can see it is future scopes and junction of 3D printing or additive manufacturing process, high build speed. So less time, more manufacturing, in-suit printing. So area printing is there. Hybrid manufacturing, you can mix the materials and also you can manufacture micro scale parts, small scales also can be manufactured easily. So multi-material components. So you can use number of materials in the 3D machine, additive manufacturing. Small scale features, the small scale features are there here. You can see this one, additive manufacturing is shifting from prototyping to industrial, high volume productions, promising decentralization. It is the sustainable, highly customized manufacturing. Further growth lies in multi-layer printing. AI-driven process control and large-scale productions. So large-scale productions you can do here, So that is a very, very future scope of this manufacturing, where in manually we can't do large-scale production, but here it is easy to do large-scale, large, large-scale, highly included, high cost. It is a so production speeds and also material limitations need to rigorous standard quality control. So you are having here high cost, slow production speeds, material limitations, everything. So coming to sixth, compare extrusion process, power bed, direct process here. So you can see what is the extrusion bed In extrusion bed, filament is used. In the power bed, powder is used. In the direct energy, DED, wire or powder is used. This is a low to moderate accuracy is there. This is very high accuracy because powder bed is used here. And the direct energy is a moderate it requires a post machining process. You can write 2 to 3 points here and diagrams here in the comparison state. So coming to this one, explain the advantages of the additive manufacturing over this one. So what is this is coming to definition. Additive manufacturing offers there are large of advantages what enables complex production of complex shapes means very complex critical designs can be manufactured. So light and weight materials can be manufactured, highly customized geometries without need of expertise tools. So instead of using tools, we don't use tools here, and less cost here. Directly the material is melted and it is deposited. So that is the one of this one. No molds are used. So no molds, no patterns. That is also saving money here. So layers, layer by layer printed here, which is more advantage, reduces material waste, no material waste, accelerating prototyping. So you can see in the diagram prototypes are created before production, which will be any mistakes you can error here. So many advantages here So here advantages of additive, you can see thermal flexibility, no heat is generated, material efficiency, more material, complex geometries, fewer steps, more less steps, 3 4 steps. Manufacturing is done. So that is the explanation of that one advantages. Eighth question, if I am taking, explain the criteria of additive manufacturing process based on the materials So materials, this definition is saying here you are having units of manufactured volume, break-even analysis. Conventional manufacturing is here, break-even analysis. Additive manufacturing is here So cost per unit manufactured is there. So cost, higher cost per unit, lower cost per unit. So low cost only these products are published. More units are produced here, less units are produced in the olden ideas. So additive manufacturing in the diagram you can see. Okay. So what is happening here? Okay. Manufacturing process requires matching materials like metals, polymers, ceramics with applications ma. There is a need for the cost, speed and geometric complexities. So metals you are using here selection, metals, polymers and applications. It is less cost, more speed, geometric complexities can be produced, and also it uses materials like compatibility, requires mechanical properties. Here strength is there, hardness is there, volumes are built, surface finish is good, everything all are considering here. So you can production volume you can see ma, low volume customized parts favor here, high volume scenarios like 10,000 plus units can be produced here ma. Okay, within no time, maybe more economical and traditional methods like injecting molding only. So that is the explanation of that one. So ninth question, describe the direct energy deposition additive manufacturing process ma. Here you can see this is a direct ma. This material wire is coming here and electron beam is coming here. Both are mixing at this point. So this is melted. This wire is melted and deposited on this part layer by layer ma. This is a build platform. This is one of the method here as I shown in the classification. So this is material is in the form of powder coming through the nozzles or wires is directly fed into localized high temperature smelting process. Energy source focusing. A layer energy electron beam and plasma arc that acts as a heat source converging with the material feed at the exhaust part of the substrate. So as I said, wire is coming directly, electron beam is coming, it is melting, it is directly depositing. That is the done of this one. So with this, I am completing this 9 questions which are very, very important in the fifth unit. Okay. The first and the last are very, very important in this unit. This is steps involved in additive manufacturing and direct energy method is very, so extrusion method is important. Here 3 to 4 questions which are very, very important. So you have to read and you have to just share with your friends. If any suggestions, please write here. I will be updating in the next videos. Thank you, ma. Thank you.